sequence.
Introduce yourself and your team.
I thought I use the time to introduce our team here that's here today. On stage, we have Monika Moshi-Broczka from the Radboud University, working on theory and imaging of black holes. Luciano Rizzola from the Goethe University in Frankfurt. We have Eduardo Ros from the Max Planck Institute for Radio Astronomy. And we have Anton Census, the director of the Max Planck Institute for Radio Astronomy in Bonn, and also chair of the board of the Event Horizon Telescope. And we have, a lot of team members here in the front row. Michael Kramer was already mentioned, our co-PI. You have Remo Tilanos, the project manager of the Event Horizon Telescope. I'm glad you're here with us today. Colin Lonsdale, who is the co-chair of the Event Horizon Telescope project. Now we have to start with the session. We are looking into space, towards a galaxy, a giant galaxy, 500 billion light years away from us. Sorry, 500 billion kilometers away from us. Very big galaxy which was suspected to host a supermassive black hole in the very center. 101 years ago, someone discovered a streak of light, which is plasma shooting out of the center of the Milky Way, marking the supermassive black hole. I never believed that this black hole was as big as people said, until we saw that. This is the nucleus of the galaxy M87, and this is the first ever image of a black hole. Das ist das erste Bild eines schwarzen
This is the first image of a black hole.
C'est la première image d'un trou noir. What you are seeing here is the result of many people working together. You have probably seen many images of black holes before, but they were all simulations or animations. And this is so precious to all of us because this one is finally real. What you're looking at actually looks like a ring of fire. And it's actually created by the force of gravity, by the deformation of space-time, where light actually goes around a black hole, almost in a circle. And that creates that circle that we see here. It has a diameter of, I forgot the number actually. 100 billion kilometers. Now I got it right. It has 100 billion kilometers. But actually, at the distance, at the huge distance of M87, it actually will appear as a mustard seed in Washington, D.C., as seen here from Brussels. The size of the ring is actually determined by the mass of the black hole and very independent of all the parameters of the black hole or the modeling. And so we can derive from that size directly what the mass is. And it's 6.5 billion times the mass of the sun. That is an enormous black hole that we see there. We see also more in there. We see this dark region in the middle. I've always been asked by my colleagues, or told by my colleagues, you cannot see a black hole, can you? And I think they're right. You cannot see a black hole, but you can actually see its shadow. And that's when the light actually disappears behind the event horizon, creating that dark region, that dark shadow we see there. And this is amazing if you think about it, where if you know the story behind that image, we're looking at a region that we've never looked at before, a region we cannot really imagine being there. It feels like really looking at the gates of hell, at the end of space and time. The event horizon, the point of no return. That is awe-inspiring to me, at least, but it's also important for physics. I think my